Hi everyone, Assalamu alaikum. My name is Dr. Bob. In this video, we're going to learn discrete random variables and continuous random variables. So our objective is describe the difference between discrete random variables and continuous random variables, and how to determine the mean for both discrete and continuous variables. As well, be able to do probability calculation for discrete and continuous random variables. So what's a discrete data? A discrete space is one in which all possible outcomes can be clearly identified and counted. We have a space here for die roll 1, 2, 3, 4, 5, 6. Similarly here, number of boys among 4 children, as is 1, 0, 1, 2, 3, 4. And for number of baskets made on 2 free throws, 0, 1, 2. Here is why discrete, data that can have a clearly finite number of values is known as discrete. Here we say 1, 2, 3, 4, 5, 6, like the finite value. So that's why we say it's a discrete data. 1, 2, 3, 4, 5 is data, and is a finite number of values. So that's why we call discrete data. And for non-discrete space data, which is called a continuous interval space, is one in which the outcomes are too numerous to identify every possible outcomes. Like a height of human beings, 0.0 inches to 100 inches is impractical to specify every possible height from 0 to 100. Similarly, if I want to say between 0 and 1, many number, although 0 and 1 is a finite number, but in finite number there is also continuous intervals, 0.1, 0.2, 0.3, and 0.001, 0.002, and so on. So we have how to calculate probability for discrete values. What is the probability that the player successfully makes at least 2 baskets? So for no baskets, probability 0.064, for 1 basket 0.288, and similarly 2 and 3. So now we have concern with at least 2, means 2 or more, 2 or 3. So for 2, probability is a 0.432, and for 3 is a 0.216. We add up like union. And then we have a 0.648. This is total probability, or actually this is a probability that a player successfully makes at least 2 baskets. And so now determining probability for continuous random variables, the probability of an event in which the outcomes are continuous is the area under the density curve for the values of x that make up the event. This is a density curve, and we have focus between x1 to x2, and this shaded area is the area. This is area under the density curve. Actually, we do find probability for a continuous random variable. Actually, we do area under the density curve. So like here, for the height of sample of women has a distribution of approximately, it's normal distribution is mean is 64.5 and standard deviation is 2.5. And now what is the probability if we pick up one woman at random? Then her height will be between 68 and 70 inches. So between 68 to 70, these are samples. So we have a density data. So density curve, so we have focus between 68 to 70. Now we transform in Z transformation. Z is x minus mean divided by standard deviation. So x here is 68 for x is equal to 68. We have 68 minus mean is 64.5 plug in, and standard deviation we have given 2.5 in question, so it becomes about 1.4. For x is equal to 70. z is equal to 2.2. Here z is equal to 1.4, z is equal to 2.2. So we are going to calculate between probability, 60 to 70. So we do 2.2 minus 1.4, and then in probability z 2.2 minus probability z 1.4. Actually, probability of z is equal to 2.2 is 0.9861 minus probability z is equal to 1.4 is 0.9192, and we have 0.0669. So this is the probability. Actually, what we have done, the area under the curve for the interval in this interval. So actually, we calculate intervals between this region. So like that, here, what is the probability randomly encountering a value for q that falls between 0.3 and 0.7? Here's data, so 0.3 to 0.7. Now we are calculating, probability. Actually, what's probability for this continuous random variable, right? So actually, we do like area. So 0.7 minus 0.3 is like 0.4. 0.4 times the height becomes area, and which is equal to probability of random variables. So here is 0.7 minus 0.3 multiply 1 is equal to 0.4. This is area, and as well as probability. So now the same question, but the height of a sample of women has a distribution of approximately 64.5 is mean, 2.5 is standard deviation. What is the probability if we pick one woman at random, what her height will be? 67 inches. What's wrong here? We cannot calculate probability, because here we picking up one woman from random variables, but we want to know just only her height at this inches 67. It's impossible. We cannot say that continuous variables, it is not possible to determine the probability of single value, right? Should not be single value. We can only determine the probability of a range of values, not single value, range of values. So calculate the mean of a random values, and how to calculate. So we have values x1, x2, x3, and so on, xk, and same corresponding x, and we have its probabilities p1, p2, p3, and so on. And how to calculate mean of discrete random variables is mean mu, we denote it like mu x is equal to x1 times p1, x2 times p2, x3 times p3, xk times pk, and we add up, and then v is equal to it's a mean of discrete random variables. So now we have example: 60% shooting basketball player shoots 3 free throws, and the random variable x, which is x, is the number of baskets successfully made. So for no basket, 0, 1 basket, and 2, 3, and we have probability. So how to calculate mean? Just like 0 times 0.064, 1 times 0.288, 2 times 0.432, 3 times 0.216, right? And we add up, it become 1.8. This is the mean of a discrete random variables. So just very simple formula, just value of x times probability, and we add up all values of x, right? So in other words, out of 3 throws in the long run, this player would make up 1.8 baskets. So actually, it's the mean of discrete random variable. Actually, we call expected values. The mean of a random variable x is called the expected value of x, the other name. And similarly, like calculating expected value, this is the mean of a random variable, which is the weighted average of the possible values of x. Weighted, what is weighted? Weighted, we take each value of x and multiply it by its probability, like x times p, and we then add all those values together. This is a weighted mean, right? So standard deviations, deviation of a random variables, we have formula just like x value minus mean and power 2 times probability, its probability, and similarly we do and add up. This is standard deviation of discrete random variables. So we calculate for now I'm recalling the same question. We already calculated a mean of this data, which is equal to 1.8. Now I'm going to calculate standard deviation of discrete random variables. So what we do, x minus 1.8. So 0 minus 1.8, 1 minus 1.8, 2 minus 1.8, 3 minus 1.8. We do like same, and then we do same. We reply with probability. Here see 0.064 times 0 minus 1.8 plus 0.28 times 1 minus 1.8. We do like same, and then we have calculated 1.72, which is equal to standard deviation of discrete random variable. We denoted like sigma square, and this is actually sigma square is actually variance. We do square root of variance which is equal to standard deviation. Actually final answer is final answer is 0.85. So now I have another example. Linda is a sales associate at a large auto dealership. At her commission rate of 25% of gross profit on each vehicle she sells, Linda expects to earn $350 for each car sold and $400 for each truck. Linda motivates herself by using probability estimates of her sales. For a sunny Saturday in April, she estimates her car sales as follows. Today is Saturday, and now, but month is not April, now it's March. I'm sorry. Anyway, so car sold 0, 1, 2, 3. A probability we have given. For similarly for trucks sold, probability also given. So now we're going to calculate what is Linda's expected incomes. So Linda's expected income is actually the mean. How we can calculate mean, like x times p, right? So for cars, 0 times 0.3, 1 times 0.4, similarly, and 2 for 3 is 0.3 multiplied 0.1. This is a mean for cars, and a mean for trucks. Similarly, 0 times 0.4, 1 times 0.5, 2 times 0.1, 3 times 0, and then this is a mean for both, and for cars, and this is for trucks, and then we add up. So this is total, expected incomes. So thank you for watching. Please subscribe my channel, and please also share to your friends, your colleagues. Thank you for watching again. Bye bye.